Hi everybody, my name is Adolfo Wiernik. I'm the Regional Director for Costa Rica, and I work as an independent consultant specializing in architecture. Today we're going to talk about 10 tips to improve your app's performance. Since we only have 10 minutes, then we're going to just go straight to the basics and the main practices you have to do to improve your performance. Lesson number 1 is performance is not an automatic feature. You need to prove that you need performance, you need to design for performance, you need to analyze for performance. .NET will not give you performance as an automatic feature built in. Based on that, you need to take care of performance from the beginning of the project. It means that while you're envisioning the project, you need to take into account what your performance needs are and what your cost will be. It should be part of the analysis you do, it should be part of the design you make, it should be part of the development and the testing. From testing, you can take all of the data you need to know when you're reaching the level of performance that you designed for. Lesson number 3, performance is about expense management, meaning that performance is actually managing your costs. You have to know how much you want to spend building a certain feature to get a certain performance level. So you have to be very sure of what your needs are, and you have to be very sure on what your service level agreement is and what your users are expecting from you in terms of the management you do on your resources. So which resources you have? We have a memory, we have a disk usage, we have network, and of course we need to plan to all of this. Lesson number 4, there are tools that inside .NET and inside Windows that help you reach that level. For some of them, the most used ones are at least the CLR Profiler and the Windows Performance Monitor. We're going to see a quick demo with the CLR Profiler. And this is a free tool that you can download from msdn.microsoft.com. You can search for CLR Profiler. It's currently on version 2.0. But with this tool, you can profile a certain application, and then you can browse and investigate the usage of certain resources inside the application. For example, you can see the call graph and see which method is calling any other method, the number of calls that it causes, and the number of callbacks that you can get back. You can also look for the amount of time that this method is taking and is executing. Another interesting one is the allocation graph, where you can see what the main instances you have in memory and their weight in memory. For example, right here in this example, I have an array of strings that it takes 2.7 gigabytes of memory and 100% of CPU to process. This, of course, will give you very coarse information for you to tune up your application. And you can change the scale, you can change the amount of detail you want to see. So it's a great tool. If you use it with Performance Monitor, you can really pinpoint your bottlenecks and exactly tune what you need. In terms of bottlenecks, of course, in our computer, in our architecture, we should look for bottlenecks in our processing, networking, I/O operations, and memory. Each of those resources will have different points in time where they can get into a bottleneck. If we're talking about processing, you should be looking for optimizing the garbage collection. You need to know exactly how garbage collection works. For example, that it's partitioned in 3 heaps and in 3 generations. So generation 0, it's the one that you're going to be used more for the newest objects. If you have a very large amount of objects, or you have a very large objects, very heavy objects, you're going to be using certain different types of heaps on memory, which will cause a bottleneck. You should also pay attention to multi-threading. Asynchronous calls are also very good, but if you have just a single processor, then the context switching all the time might not be that good. Hardware interruptions, if you have a lot of networking or a lot of I/O operations, might be also causing a bottleneck for you. And if we go to the next resource, for networks, you should pay attention to the type of the data types that you're using. For example, if you're using a large amount of data sets, or your data sets are really full with data, and you move them through all the layers in your application, it might be causing a bottleneck on the network. The amount of data sent is something that you have to pay attention to, and you can pinpoint that problem using the performance monitors and checking exactly the amount of data that you're sending, checking the amount of sent bytes and received bytes. Chatty up interfaces, of course, it's something you should avoid. And if you do a very well service-oriented architecture, of course you will not get into this problem. In terms of I/O operations, the number of assemblies you have, the size of your assemblies, how you distribute your classes into assemblies will affect the number of times that the loader has to take an assembly from disk, move it into memory. You should, of course, monitor your page faults and see all the times that the memory processor needed to go to disk back again to bring a certain assembly into memory. Last but not least is memory management, where you should avoid certain operations, especially if you're doing concatenation with strings inside loops, or if you're managing shared state, or if you're doing destructors. All these things affect the amount of memory and the way that the garbage collection is working. Complex memory structure, as I said before, data sets, arrays, or any other of generic collections might also be causing a bottleneck. And the last point is COM interrupt. If you're working with single thread apartments and objects that you wrote in VB6 or any other COM language, they might be affecting also because they need to live in that single apartment and might be causing a latency with your threads. The last lesson is basically test and monitor all the time. You should be monitoring your application all the time, because in this way you know if you reach the level of performance that you need. If you want some more information, you can check on the Patterns and Practices website and basically search for this book, Improving .NET Application Performance Scalability. It's a huge book, but it's very worth reading it. I hope my English is good enough for you to understand what I'm saying, but drop me a line if tell me your experiences with performance and we'll get in touch. Thank you.